My name is Hunza Cedric, and representing a machine learning model for interpretable machine learning techniques for students' grade prediction. The model used was graph neural networks, and well, the steps involved include data preprocessing, where we chose features, we cleaned the features, we cleaned the data, and then preparing the model using one-hot decoding. Chose a deployment environment. Here we used render, and then containerizing the model. Then just deploying the containerized model, and then monitoring and scaling. The open source tools used, we have MLflow, Grafana, Dev Container, where MLflow is for monitoring the performance, and then it has also the logs for the model. And then Grafana Prometheus also for visualizing the performance and uptime in different areas. And then, yeah, moving on. With MLflow, MLflow is an open source platform for managing the end-to-end machine learning cycle, that is experiment tracking, reproductivity, and model packaging.
My name is Namakula Josephine, and I'm starting on MLflow tool, which is an open source platform for managing the end-to-end machine learning lifecycle. First of all, it is used for experiment tracking. It is used for reproducibility and model packaging. So experiment tracking, MLflow allows you to log parameters, code versions, metrics, and artifacts when running your machine learning experiments. It also provides a centralized location to log and query experiments, making it easier to compare results and track model performance over time. So when we go to MLflow, first of all, this is how our structure looks like. So when ML runs, so every time the code that trains the model is run, it creates an ML run for it. So an ML run consists of the performance information about the version of the model deployed. It also keeps track of the version. So this one here is the ML is our ML run folder where we can find the number of runs we have done. So here, this is the MLflow, the code where I implemented the MLflow. We will discuss the code in our VS Code. Here, this is the link we get when we run our MLflow to go to the MLflow dashboard. So MLflow, this is the MLflow dashboard. These are the run names we get every time we run the what? We run the ML. So,
good evening. My name is Samanga Trevor McDaniel, and I'm here to take you through Grafana and Prometheus. So Grafana and Prometheus are literally supposed to help us track our models' availability. It is more of availability, whereas the MLflow part is for performance. So these are the steps taken. We're literally going to just install Prometheus, instrument model, configure the Prometheus and all that. Let's just get right into it. So if you to look, this is the Grafana screen. This is like the dashboard. So you kind of see where your model's uptime, reachability, the average latency, and the frequency. So the higher these values are, the more available your model is. And every time the uptime goes down, it means that there was a certain time where your model wasn't available. It wasn't reachable or available for yours. And yeah, same implies there. Shall look more into it when you get into that part. So when the deployment part, we're deploying on render. And as we're deploying, we tried very many other times, but until we got a breakthrough and we were able to deploy. Then for the render, why we use render, there is easy deployment when we are hosting on render. There is automatic scaling, high availability. Render is, when you host something on render, it is easy to access and all that other stuff. So integrated continuous integration and continuous deployment, monitoring and logging, etc. Then the dev container, this is more for containerization because sometimes our model relies on other packages. So since it relies on those other packages, we need to put it in a container, probably a Docker container, but kind of use dev container. So that will be able to put the dependencies with the model so that it can actually perform well. So the impact of implementing this thing, version control. So we use Zen ML and ML Flow. And yeah, some of the points are going to have similar names. So for the Zen ML Flow, it enables version control and tracking. So we be able to know which version of our model is actually working. It's easy to deploy on Zen or ML Flow. It will be harder to deploy models if we didn't include them. Then collaboration and those other things. Yes. Yes. So for the ML flow part, there is easy deployment. It promotes collaboration where multiple people can work on the project. And yeah, there is continuous integration and continuous deployment. So yeah, thank you so much for listening.
Okay, so now, like I said, we began with processing the code, processing the data. So now here, data processing, we began by defining a class data processor, and then we defined a function, separate targets and features. Here we define the targets here as average one, and then the features, and then we had to standardize the features, whereby we had to look for the numeric features that can be used to train the model. And then we continue to standardize the features here, where with this function here. And then here we split the data into test data. And then we continued, and then we went on to training the data. For training the data, you put the variables, and then find the function training model that had those arguments. And then we also defined ML flow tracking at that IP address, and then we added in the ML flow runs where we define the train losses and the train accuracies where it would log them, and then we also define the epochs with the running just starting at 0.0, and then we had the inputs, and then for the inputs and labels for the train loader, where we also defined the optimizer and the output of the model, and then we also defined the loss function, and then then we continued. Then we also defined the evaluation, where we're using R2, the R2 score, and then here this prints the apertures, and then the loss, and then the accuracies, because there's a evaluation. And then here this function here brings the logs for error flow that we shall see in the as the video continues. And then here we define the function to save the model. Yes, and then for evaluation of the model, we inputted the libraries, and then we define the function for evaluating the model. And then we have inputs, labels for the data loader, and then we have our output, and then we have our evaluation here, which is R squared, and then everything is saved in the what? It's logged in the ML flow in ML flow.
So when I start from where my colleague has stopped, so here we have data. In this folder, we have where our CSV file is kept. So we also have ML runs. So these ML runs show it shows the number of runs our build model has been able to be successful in building and running. So these are the successful runs we have in our model. We also have in this folder, it includes our virtual environments. So in the ML runs, so we go to app.py. In app.py, here we load our training model. We have our model URI in ML runs. So we also have functions. This one is processing the data. This is our route. This is our route, which we also get the input data. This was done statically. So here we convert the JSON data into pandas data frame. We process the data. We convert the data into tensor data. We feed the training model with data to make predictions. So when we come to, let me stop sharing this screen. So I share another screen. So when we run our ML flow in the command prompt, like ML flow UI, it gives us a URL, it gives us a URL. So this URL brings you to this page. So this page, it shows the number of runs in which I showed you in the ML runs. These are the run names. This is when it was created. This is the duration. It comes from main.py. These things here, the Python things, it shows it is where it was. It is where our data is stored.
Okay, so regarding running the model, after all the other files that my colleagues have explained, we come and run everything in the main.py. So the main.py references all the other Python files so that we can be able to see the output. So we begin by loading the data set, processing the data. We already saw the file that does that. Instantiate the model. We get the loss function and all the other things. The epochs, which we're going to run 500 up to the end. So allow me run this file so that you see the output of it. Yeah, let me pull up my console to show me what it is doing. Okay, a minute to run this. So yeah, the model finally ran and were able to train it throughout these epochs. Started by performing badly. Let's go down, 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 down. And we finally achieved the accuracy as this. Yeah. So after doing all that, then we go to the what? We know that our model works, and so we have to go to the step of deploying. Now, if you have to look at deploying, use render. Let me share the screen with you where render is. Where is my render? My render share this, and so our render is here. We have finally gotten there. So we tried, like I say, and we finally got one model to deploy. So when we go to that model that we deployed, we find the link where we can actually access the model. So this is the link that you have to go to in order to be able to access and interact with the model. Then when you scroll down to the settings, here they provide us with, they show where the model is deployed, the region in which it was deployed, how it is using up resources, and all the other things. And then here, it shows us the GitHub repo where we can access it, and the requirements file that installs the requirements that are needed. And then we use Gunicon because sometimes the dependencies that we are running with are not the same as those ones on the server. So we have to use Gunicon to kind of like perform a handshake. I can call it a handshake with the rest of the work. Then it also offers us an API here that we can use to access the model using maybe other ways from another application, a third party or something like that. So that was render. And then the other process would be through the GitHub. And on GitHub, it is where we use the dev container. It is what we use to do the containerization of the dependencies that we need to work with our thing. So our model uses other libraries to run. So we kind of do the dev containerization thing so that we can be able to get it run. Yes. And if you are to go to Grafana, like we said initially, Grafana is how we monitor the reachability, the availability of our model. I can save an application. So the uptime and then the reachability. So the reachability here reduced because there is a point here where our model wasn't accessible. Something like that is it. And the uptime, if it's available, if you hit the route at which it is found, and yeah, so our model can easily be our model is deployed. Here we can see the performance and the rest of the things, the latency, and all the others. Yeah, thank you so much for listening to me. That marks the end of everything. Yeah, have a good evening.